shell in the manufacturing process and everything that goes into creating the body of the car. Basically, it started out with our CAD models on the computer. We spend a lot of time in the digital world making CAD models and then refining them and getting them exactly to the shape that we want the car to be again. We send those files over to a company. We use a company called APW, Advanced Pattern Works. And so what they did was they took a giant block of high-density foam. And what they did was they did a computer-controlled machine milling process. So they take this big machine, and it has a tool on the end that spins around, and it carves into the foam. And what it does is it refines that shape and gets the foam to the shape that's exactly like what it is in the car, what it's supposed to be in the car when the final model is. They did that in two pieces, the top and the bottom. And then those big foam plugs, they're called, they ship those by truck on a flatbed over to us. So we moved those in here. Then what we did was we made fiberglass molds off of those. So the plugs are like the male molds, and then we made fiberglass plugs or fiberglass molds off of those that were female molds. So basically what that involves is taking fiberglass sheets and laying them on top of that the foam molds that were sent to us, and then applying epoxy to them. And then what that does when it cures and dries and everything, it creates sort of like the negative image of what the actual car is supposed to look like. So we take that, and when it dries, we pop that off of the foam plug. So we have this negative fiberglass model of the car. We flip that around, and then what we did with that was we took those negative fiberglass models and took those up to Roush up in Detroit. Roush is the performance division of Ford, and they specialize in body work and composites and layups and things like that. And so from there, we take carbon fiber, pre-impregnated carbon fiber, and lay that into those negative fiberglass molds. So that pre-impregnated fiber, or pre-impregnated carbon fiber is different from regular carbon fiber, in that you don't have to apply this wet, gooey epoxy to it. So when you lay this pre-impregnated fiber into the negative fiberglass molds, you stick it in the oven and heat it up and let it cure. And then once it cures, it's nice and hard, you pop that out, and then you have a carbon fiber exact replica of what our original foam thing was, and which is the same as our original model in our computers. And that's what we use with the body. That's what the body is. That's the final product that you get. From there, what we did is, so we had two pieces, the top and bottom. We had to do a whole shell mating process. So it's split here along the seams in the top and bottom. And we have to line them up and join them together with carbon fiber strips internally and on the outside. And then from there, once we finish it and sand it down and get it as smooth as we can, we sent it over to Dempster Auto, which is one of the automotive companies in the area, and we had them paint it for us. So they put a nice clear coat on it so we could leave all the carbon fiber exposed. And then beyond that, we just apply logos to it, and we have our body. And that's the very brief overview of the shell manufacturing process. Okay, so the purpose of the shell to the overall car is, first, it's obviously the first barrier in a crash, and it encases everything, and it obviously reduces a lot of the drag. It covers everything up, and it allows the wind to flow over it smoothly and for it to cut through the air. The shell also serves the purpose of allowing us to put the cells on. And obviously, we need a big flat area to put the cells on, and we have the shell on which to do that. And then finally, the shell serves as a protective barrier. We have the internal metal frame, the chassis, but again, the shell is what is going to come in contact first with something. And carbon fiber is a very strong and lightweight material, and so it does serve a protective purpose as well.
Okay, so the first part of the car that we're going to go over are the battery system. We run on 624 lithium-ion batteries. You can see we have 24 cells in parallel and 26 of those bricks in series. That gives us a nominal voltage of about 96 volts, which is what our motor runs off of. And attached to these batteries is our battery protection system here. We have a bunch of difference amplifiers if you want to come in and take a look at these closer. These difference amplifiers here step down the voltage and basically measure the voltage between each individual brick of cells. And then those voltages are multiplexed into our Wolf onboard microprocessor here to make sure that they're within the valid range. We also have temperature sensors throughout the battery pack that are also multiplexed into the Wolf, and the temperatures are checked to make sure that they're within a valid range. And finally, we have current sensors on the output of the batteries that measure, continuously also measure the current to make sure that we don't go over current or charge the batteries too much.